For low voltage lighting fixtures operating at 12 volts, selecting the appropriate wiring type is crucial. There are a few suitable options. Firstly, Class 1 wiring with wiring method CA is a viable choice. Secondly, Type CL2 or CL3 cable is specifically designed for low-energy, power-limited circuits, and is also acceptable. Thirdly, Class 2 wiring, specifically wiring method CM, can be considered. Lastly, Type CM cable is commonly used for communication and signaling circuits. When installing wiring in a non-plenum rated grid ceiling, proper support is essential to prevent damage and ensure the electrical system functions correctly. J-hooks and wire ties are a practical solution. Install them along the beams or grid of the ceiling to securely hold the wires in place. Wire baskets or trays offer another option, allowing you to bundle and support multiple wires. Cable channels provide a dedicated pathway for the wires, protecting them and keeping them organized. Several additional factors warrant careful consideration. Firstly, selecting the appropriate wire size is critical. Base your choice on the load requirements of the lighting fixtures and the distance the wires will travel to prevent voltage drop and overheating. Secondly, transformers should be mounted in a secure and accessible location within the ceiling area for easy maintenance and replacement. Thirdly, take steps to protect the wires and transformers from physical damage, moisture, and extreme temperatures to ensure longevity and safety. Fourthly, it's essential to ensure that the transformers and wiring are properly grounded in accordance with electrical codes to prevent electrical shock hazards. Lastly, upon completing the wiring, thoroughly test the system to verify its functionality and compliance with applicable standards. Based on the provided information, a recommended wiring plan involves using Type CL3 cable for the low voltage wiring. Secure the wires using J-hooks or wire ties to maintain proper support. Install transformers strategically, such as for every 4 or 5 light fixtures, to efficiently power the system. Take precautions to protect the wires and transformers from damage to enhance system reliability. Conduct comprehensive testing upon completion to confirm proper operation. To further clarify, let's delve into each of these points in more detail. When selecting wiring, it's important to understand the differences between Class 1, Class 2, and Class 3 circuits. Class 1 circuits generally operate at higher voltage and power levels, requiring more robust wiring methods and protection. Class 2 and Class 3 circuits are power limited, meaning that the voltage and current are restricted to reduce the risk of electrical shock and fire. Type CL2 and CL3 cables are specifically designed for these power limited circuits, offering enhanced safety features. Type CM cable, while commonly used for communication circuits, can also be suitable for low-voltage lighting applications, but it's essential to verify that it meets the specific requirements of the lighting system. When supporting the wiring, consider the weight of the cables and the spacing between supports. J-hooks and wire ties should be installed at intervals that prevent the cables from sagging or straining the connections. Wire baskets and trays offer greater support for multiple cables, while cable channels provide dedicated pathways that protect the wires from physical damage and environmental factors. The selection of the appropriate wire size is crucial for ensuring proper voltage delivery to the lighting fixtures. Use the National Electrical Code (NEC) tables to determine the minimum wire size based on the load requirements, wire length, and allowable voltage drop. Undersized wires can overheat, leading to insulation damage and potential fire hazards. Transformer installation requires careful attention to location and mounting. Transformers should be accessible for maintenance and replacement, but also protected from physical damage and environmental factors. Ensure that the transformers are properly mounted and secured to prevent them from falling or shifting. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault currents, helping to prevent electrical shock hazards. Ensure that the transformers and wiring are properly grounded in accordance with the NEC requirements. Upon completing the wiring, thoroughly test the system to verify its functionality and compliance with applicable standards. Use a multimeter to measure voltage and current levels and check for any shorts or ground faults. Verify that the lighting fixtures are operating properly and that the system is functioning as intended. Type-C L3 cable is a good choice for low-voltage lighting wiring due to its safety features and suitability for power-limited circuits. Securing the wires with J-hooks or wire ties ensures proper support and prevents damage. Strategic transformer placement, such as for every 4 or 5 light fixtures, provides efficient power distribution. Protecting the wires and transformers from damage enhances system reliability and longevity. Comprehensive testing upon completion verifies proper operation and compliance with applicable standards. Now let's consider some specific examples. Suppose you're wiring a series of 12-volt LED pendant lights in a restaurant. Each light consumes 5 watts. If you have 5 lights per transformer, the total load on the transformer is 25 watts, calculated by multiplying 5 watts per light times 5 lights. At 12 volts, this corresponds to a current of approximately 2.8 amps, determined by dividing 25 watts by 12 volts. You would need to select a wire size that can safely handle this current over the distance from the transformer to the lights. According to NEC Table 310.15, B16, for example, a 14 American wire gauge OG copper conductor with a temperature rating of 75 degrees Celsius is typically sufficient for carrying 15 amps in most common wiring applications, which would be more than adequate for this low current application. However, factors like ambient temperature and conduit fill could affect the ampacity of the wire, so it's always best to consult the NEC and a qualified electrician for specific requirements. The support J-hooks can be installed every 4 to 6 feet along the ceiling grid to secure the wiring. The transformers should be mounted in an accessible location, such as above the ceiling tiles, and protected from moisture and excessive heat. The transformers and wiring should be properly grounded to the building's grounding system. After completing the wiring, test the voltage at each light fixture to ensure that it's within the acceptable range, typically plus or minus 5% of the nominal voltage. This ensures that the lights are operating at their intended brightness and efficiency. Another example is wiring a larger number of low-voltage lights with a longer wire run. Suppose you have 10 lights, each consuming 3 watts, for a total load of 30 watts. At 12 volts, this corresponds to a current of 2.5 amps. If the wire run is 50 feet, the voltage drop can become significant, especially if using a smaller wire size. In this case, you might need to increase the wire size to minimize voltage drop and ensure that the lights receive adequate voltage. Using a voltage drop calculator or consulting the NEC, you can determine the appropriate wire size. For example, increasing the wire size to 12 AWG might be necessary to keep the voltage drop within acceptable limits. In addition to wire size, consider the type of insulation used in the wiring. Some insulation types are more resistant to heat and moisture than others, making them more suitable for certain environments. The NEC specifies the types of wiring that are permitted for various applications, so it's important to follow these guidelines. When installing transformers, consider their efficiency and heat generation. Some transformers are more efficient than others, meaning they waste less energy in the form of heat. High-efficiency transformers can help reduce energy costs and prevent overheating. It's also important to provide adequate ventilation for the transformers to dissipate heat and prevent premature failure. Regular inspection and maintenance of the low-voltage lighting system can help identify and address potential problems before they become serious. Check the wiring for any signs of damage or deterioration and ensure that the connections are tight and secure. Inspect the transformers for any signs of overheating or malfunction. Replace any damaged or worn components promptly to maintain the system's safety and reliability. The NEC provides detailed requirements for low-voltage wiring installations, including conductor sizing, overcurrent protection, and grounding. Familiarize yourself with these requirements and follow them carefully to ensure a safe and compliant installation. Consult with a qualified electrician or electrical inspector if you have any questions or concerns. They can provide expert guidance and ensure that the installation meets all applicable codes and standards. By following these recommendations, you can create a safe, reliable, and efficient low-voltage lighting system for your restaurant. Remember that proper planning, careful installation, and regular maintenance are essential for ensuring the long-term performance of the system. Keep accurate records of the wiring and transformer locations for future reference. Label all circuits and components clearly to facilitate troubleshooting and maintenance. Provide training to the restaurant staff on the proper operation and maintenance of the lighting system. This will help them identify and report any problems promptly. Also, consider using energy-efficient LED lighting fixtures to reduce energy consumption and lower operating costs. LED lights are much more efficient than traditional incandescent or halogen lights, and they have a much longer lifespan. This can result in significant savings over the life of the lighting system. Think about incorporating lighting controls, such as dimmers and occupancy sensors, to further reduce energy consumption. Dimmers allow you to adjust the light level to match the needs of the space, while occupancy sensors turn off the lights automatically when the space is unoccupied. These controls can help save energy and extend the lifespan of the lighting fixtures. Consider the aesthetic aspects of the lighting system as well. The lighting should be appropriate for the ambience of the restaurant and enhance the dining experience. Use different types of lighting to create visual interest and highlight architectural features. Pay attention to the color temperature of the light, as this can affect the mood of the space. Always consult with a qualified lighting designer to develop a lighting plan that meets your specific needs and aesthetic goals. It is extremely important to emphasize safety throughout the entire process, from planning to installation to maintenance. Low-voltage lighting systems are generally safer than high-voltage systems, but they can still pose electrical hazards if not installed and maintained properly. Always disconnect power before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and standards. Seek the advice of a qualified electrician if you are not comfortable working with electrical equipment. Remember, electricity can be dangerous, so always take precautions to protect yourself and others. Regular maintenance is the key to ensuring the long-term performance and safety of the low-voltage lighting system. Conduct routine inspections to identify and address any potential problems. Keep the lighting fixtures clean and free of dust and debris. Replace any burned out or malfunctioning lights promptly. Check the wiring and connections for any signs of damage or deterioration. Inspect the transformers for any signs of overheating or malfunction. A well-maintained lighting system will provide years of reliable service and enhance the ambience of your restaurant. It is crucial to consult the latest edition of the National Electrical Code, NEC, for the most up-to-date requirements and best practices for low-voltage wiring installations. The NEC is a comprehensive set of standards that covers all aspects of electrical installations, including wiring methods, conductor sizing, overcurrent protection, and grounding. Familiarize yourself with the NEC requirements and follow them carefully to ensure a safe and compliant installation. In addition to the NEC, local codes and regulations may also apply. Check with your local building department to determine any specific requirements for your area. Always obtain the necessary permits before starting any electrical work. Consider the long-term maintenance costs when selecting lighting fixtures and components. Some fixtures and components may require more frequent maintenance than others. Choose products that are known for their reliability and durability to minimize maintenance costs over the life of the system. Establish a maintenance schedule and budget to ensure that the lighting system is properly maintained. Factor in the cost of replacement parts, labor, and other expenses. A well-planned maintenance program can help extend the lifespan of the lighting system and prevent costly repairs. Remember that the information provided here is intended as a general guide and should not be substituted for professional advice. Always consult with a qualified electrician or lighting designer for specific recommendations and guidance. By following these guidelines, you can create a safe, reliable, and efficient low-voltage lighting system that enhances the ambience and functionality of your restaurant. Remember to always prioritize safety and consult with qualified professionals to ensure a successful installation. Thorough testing and commissioning are critical steps in verifying the proper operation of the low-voltage lighting system. After completing the wiring and installing all the components, perform a series of tests to ensure that the system is functioning as intended. Measure the voltage at each light fixture to verify that it's within the acceptable range. Check the current draw of each circuit to ensure that it's within the rated capacity of the wiring and overcurrent protection devices. Verify the operation of any lighting controls, such as dimmers and occupancy sensors. Conduct a visual inspection of the wiring and connections to ensure that they are properly installed and secured. Correct any deficiencies or problems that are identified during the testing process. Document the test results and keep them on file for future reference. Commissioning is the process of verifying that the lighting system meets the specified performance requirements. This may involve measuring light levels, uniformity, and color rendering. Compare the measured performance to the design specifications and make any necessary adjustments. Provide training to the restaurant staff on the proper operation and maintenance of the lighting system. A properly tested and commissioned lighting system will provide years of reliable service and meet the needs of your restaurant. It is important to consider the environmental impact of the low-voltage lighting system. Choose energy-efficient lighting fixtures and controls to reduce energy consumption and greenhouse gas emissions. Dispose of old lighting fixtures and components properly to prevent pollution. Consider using sustainable materials and construction practices. A well-designed and maintained lighting system can contribute to a more sustainable and environmentally friendly restaurant. In summary, wiring a restaurant with low-voltage lighting requires careful planning, attention to detail, and adherence to applicable codes and standards. By following the recommendations outlined above, you can create a safe, reliable, and efficient lighting system that enhances the ambience and functionality of your restaurant. Do not forget to prioritize safety, consult with qualified professionals, and maintain the system properly to ensure its long-term performance.